Hi everyone. We're going to continue to talk about functions and parent functions and their graphs today, but we're specifically going to talk about how to transform them. So when I say transform them, we know what a basic parent function looks like now. Say it's a parabola, but how do you transform them to look like other versions of themselves or less simple versions of themselves? So how do I make them wider? How do I flip or reflect them? That's what we're going to work on today. There are a few different types of transformations we're going to talk about, and I hope you heard some of these words before. First, we have translations, which is going to move our graphs up, down, left, right, horizontally, vertically. We have reflections, and we have different changes in size. So how do you make something wider or thinner? In other words, stretch or compress that graph, that function. Now, before we get started, I just want to review a couple of quick things. First of all, this left-right movement, that is the x-axis. Okay, up and down movement is the y-axis. And that's really important in transformations because if you're going to transform the x, you want to apply to the x variable. If you're going to transform the y-axis, you want to apply to the y variable. And when we talk about horizontal movement, okay, left and right, that's the x-axis. Vertical movement is the y-axis. For the purposes of this video, I'm going to graph one of our parent functions. Remember, a parent function is the simplest of all functions. So right now, what I'm graphing is the absolute value function, or the parent function for it. Remember, it's just a V shape like so. Okay, and the equation I just graphed would be y equals the absolute value of x, which again is those bars. I'm going to show you how you could move this absolute value graph up, down, left, right. I'm going to start with up or down because it's a little bit more intuitive. So let's say I want to move this graph up 3. Well, I just count up 3 on each point. 1, 2, 3. I'm only going to do a few points. 1, 2, 3. And you would be able to move it graphically. But how do you change the equation to make this happen is what I want to talk about. Okay, so I moved it up 3. This y coordinate now is 3 instead of 0. This one is now 6 instead of 3. I moved it up 3. So in order to move it vertically, you're going to add or subtract something to the entire function. So I started with y equals absolute value of x, but I moved it up 3. So you're going to take the function, which is like your y, and you're going to add 3 to it to get the green function. Okay, let's say you want to move it down, and we're going to move it down 2. Well, you would go down 1, 2 on every point graphically, and then again, you would be able to graph that vertical translation of down 2. So if you want to move it down, well, this coordinate went down 2. So instead of adding to the function, you're going to subtract 2. Okay, to summarize that, actually, we're not going to erase that. But to summarize that, if you want to go up, you would add some number to the whole function. And if you want to go down, you would add some number to the whole function. And I'm just calling it k as a placeholder. K could be any number. So in this case, k is 3. In this case, k is 2. So you're subtracting or adding a number, again, to the whole function. So I'm even going to be a little bit more specific on this, actually. I'm going to use my example. So you would take the function, and you would add some number. Or you would take this function, and you would subtract some number. And the nice thing about transformations is no matter what function you're dealing with, they all work the same. So let's say I didn't have an absolute value graph, but instead I had a parabola. Okay, just keep erasing for a second. Okay, you get the idea. So a parabola would look something like this. I'm not drawing it accurately, but let's say I want to move it up to, well, this is what would happen. So your parent function is y equals x squared. You want to move it up to, all you would have to do is add to your whole function, to the x squared. So again, it doesn't matter what your function looks like. These transformations are going to work exactly the same. So you would either add or subtract some unknown value to the original parent function. Okay, now we're going to talk about moving our graph horizontally. But real quick, I'm just going to get my absolute value graph back up. So that was a good one to look at. Okay. So visually, let's say I want to move the graph to the right. Well, I would, let's say, go over 4 units from each point. 1, 2, 3, 4. And it would look something like this. Okay, so visually easy to move left or right. The question is, how do we alter the equation to make that happen? And unfortunately, this is a little bit less intuitive than the vertical translation. The horizontal translation is actually going to do the opposite of what you think. And the reason for that is because the function's always in terms of y. So the rule is telling you what y will do. The function is not in terms of x, right? So we don't have x equals the absolute value of y. It's not in terms of x. So it's going to do the opposite, but if you were to put it in terms of x, it would do what you think it does. But we always have graphs in terms of y, so it's going to do the opposite of what you think. So if you want to move it here right 4 units, our new equation would actually be y equals the absolute value of x, not plus 4, because it's going to do the opposite, but minus 4. Okay, so if you want to move something to the left, you would take your x value, because you're applying it to the x, because we're moving it on the x-axis specifically, and you would add to go to the left. And if you want to go to the right, you would subtract some number. Actually, I'm not going to use k here because we use k below. Since we're moving it left or right, I'm going to use a different variable. I'm just going to call h. And this would work exactly the same for a parabola. So if you want to transform a parabola, you're going to apply it directly to the x because you're moving it on the x. So let's say you wanted a parabola, but you wanted to move it to the right 6 units. It would now be over here. Well, you would take your x value and you would add 6 units, and that would be your equation. But it doesn't have to be 6, it could be any number, so I'm going to call that h. Okay, or if you want to move to the right, again, it's going to do the opposite of what you think, so you're going to subtract h directly from the x value. Okay, so just to kind of summarize here, if you want to apply something to the x, you're going to add or subtract it directly to the x. But if you want to transform it on the y, you're adding it to the function as a whole. Okay, so I've erased all that so we can go on to our next transformation, which is the reflection. Okay, now for the reflection, I'm going to talk about a different function just to show you that it applies to literally any parent function. The transformations always work exactly the same. Okay, I'm going to show you a square root function. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. It would go like up here, and you get this like shooting star looking parent function. As a reminder, the equation for that parent function would be just the square root of x, right? So when I take the square root of 4 is x, y would be 2. Okay, there are 2 different types of reflections. You can reflect over the x-axis, which again is this one, horizontally, or you can reflect over the y-axis, which is this one, vertically. And I'm just going to draw what the reflection would look like, and then we can derive how you would transform the equation. So let's say you want to go over the x-axis. Okay, this point here, well, it would stay the same. This point would go this way. This point, 1, 2, 1, 2, would go this way. This point would come down here. So a reflection is just another word for essentially flipping the graph over that axis. Think of like your reflection in the mirror, you know, it flips, or in your like selfie camera, it flips the way it goes. Okay, so that would be a reflection over the x-axis. So the point is jumping or flipping across the x-axis. Now I'm just going to quickly label these points to show you what's happening. So this point was 1, 1. This point was x is 4, y is 2. Okay, this point, now x is still 1, but your y value is negative 1. This point, your x was still 4, but you're going down negative 2 on the y. So what has changed? Your x has stayed exactly the same, but your y value has become negative. So if you want to flip a graph or reflect a graph over the x-axis, you're going to make the y values negative. So if my original function was y equals the square root of x, okay, in order to make the y values negative, you're going to make the whole function negative, and you would put the negative in front of the graph function, parent function. Okay, works the same if you want to apply it to a parabola. You would make the whole thing negative. Not just the x, but the whole function. I could even put that in parentheses. You don't really need to, but you could. Or if I want to do absolute value, you would make the whole absolute value function negative. Okay, so you need to make the y value negative. So I know it's a reflection over the x-axis, but as you can see, the y value is becoming negative because it's going from up here to down here. It's going from positive on the y-axis to negative on the y-axis. Now we're going to talk about over the y-axis. I'm just going to erase this real quick here. We're going to start over. Okay, let's get a different color. And we are going to reflect over the y-axis. So we're going to flip or mirror over this way. So this point was here. It's now here. This point was here. It's now here. Square root of 9 is 3. Would be somewhere like around here. And then we flipped over the y-axis. You know, if you folded one on top of the other, they should match up if I drew that correctly. Let's do the same thing where I label the points. So this was 1, 1. Well, now it's x is negative 1. Y is still positive 1. This was 4, 2, but now x is negative 4. Okay, because it's gone from over here on the positive x-axis to over here on the negative x-axis. And just for fun, this would be negative 9, 3. Okay, so as you can see, the point is very similar, but what's changed is that the x value, the first coordinate, remember our points are in as xy, is now negative. So if you want to flip over the y-axis, you would make the x value negative. Okay, so similar to this, except you're applying it directly to the x. So it would look like this, or it would look like this. Or if it was a parabola, your x would be negative, not the whole function. So very similar, slightly different. And again, this can apply to any function, even if it was x to the third instead. The last one we're going to talk about is this change in size, which could be bigger, wider, skinnier, smaller. And you can do that on the horizontal, which is the x, or the vertical, which is the y. And remember back to when we talked about translations, which, by the way, translation just means to move up, down, left, or right. And the horizontal one did the opposite. For the same exact reasons, it's going to happen here as well. The horizontal or the x is going to do the opposite of what you think. So I'm going to talk about vertical first because it's more intuitive. So if you want to stretch something on the vertical, you're just going to multiply by a number. And if you want to compress or shrink it, you're going to divide to make smaller. Now, the horizontal will do the opposite. So if you want to stretch and make it bigger, you actually do the opposite and you divide. And if you want to compress, you're going to multiply by a number. Okay, I'll give you an example. So if we're talking about vertical and we're talking about absolute value graph, let's say I have the absolute value of x, you could multiply by a number like 2, and that would make it stretch. If you want to divide on the vertical, there's 2 ways to write this, but the way I prefer to write divided by 2 is just multiplying by a half. So multiplying by a half is the same thing as dividing. Okay, now if you want to do horizontal, you need to apply it directly to the x. Okay, but remember it does the opposite. I know this is a lot. That's why I'm writing it all out, and I suggest you do as well. So if you want to stretch it, you're going to divide the x by a number. So it could be like x divided by 2, which again means the exact same thing as multiplying by a half. Okay, if you want to compress, you're actually going to multiply the x by a number. So it could be like 2 times x. As a reminder, it doesn't have to be a 2, and it doesn't have to be the absolute value. It would work the same if it was a square root function. It could be 2x to compress it, or 3x. It does not matter. Okay, so I realize I kind of whipped through this, and the reason is I want to show you what these look like on Desmos before the time runs out. So here we have a square root function. The beauty of Desmos is you can just play around with this, even though if you don't have the rules memorized. I can say, okay, I want to reflect it over the y-axis. Let me try this. Oh, wait, that reflected over the x-axis. I guess I got to move that here. Okay, or maybe I want to move it up 2. Oh, wait, that actually moved it to the left 2. So maybe I got to, boom, put it on the outside here. Or, shoot, I wanted to move it down. And then you can just play with these values and see what happens. I could multiply this by 2. Look, it got taller. It stretched. Or I multiplied on the outside by 3. Oh, it also stretched, got taller. So you can just kind of play around with what it looks like on Desmos, which will be really helpful in, creating some sort of Desmos art project. To be continued. But those are all the different transformations. Have a good rest of your night.